Yeah, welcome to this podcast. I have with me Michael Jacob. He is a senior robotics engineer at Ocado Technologies based out of London. And he's been working on this role as from the last 3 years. Before that, he has completed his PhD from University of Birmingham in computer science robotics. And prior to that, he has obtained trainings at IIT Bombay and CSIR Durgapur. Welcome to this show, Jacob.
Thank you, Manhar.
Yes. Now, Michael, like in your role and in many roles now, data science is like the most important skill that one needs to have. So, could you walk us through as to how data science is linked to your field as such? And how do you use data science tools, and in particular linear regression or maybe other forms of regression, Michael?
Yes. So, uh, in uh, in robotics specifically, the techniques we use are diverse. But then before I mention about the techniques, I would like to say why we do things with data. So, for example, when we actually write a mathematical, so when we typically how we do things, we actually write a mathematical equation or a model of a system, and then you try to actually understand. So that is how you actually understand the system, by mathematically modeling the system. But the problem is that when you mathematically model, you make a lot of assumptions in place. So, for example, from my systems, from a robotics perspective, you might think about rigid body dynamics, for example, meaning that all objects that interacts are rigid bodies, but you know for sure that all the objects that you interact on a daily basis are not rigid,
So
right?
one second.
But
So
then
these
this is
assumptions, one second. So these assumptions that you made, so they are made to ease your, understanding.
mathematical yes,
Yeah.
so it's both to help our understanding as well as derive the equation. So if you look at the history, how we have come up here is that it's easy to make these assumptions, write the equations, and then come up with a solution, right? We didn't have this much of computing power
True.
before
Yes.
10-20 years, right?
Yes. Yes. Yes.
So the only possibility we had was actually writing equations on paper, and maybe then writing simple or and then plotting various graphs on a system or something.
Yes.
So, and so the problem with that was, because of these assumptions in place, most of the time the mathematical model you write does not exactly correspond to the object or the system you are trying to model, right? The
Okay.
meaning
It's
that
a
they closely behave, but then they are not exactly the same, right?
Okay.
So the good thing is that when the model is accurate, you actually get to understand the model better, and having an accurate model of any system helps us to manipulate the system better. Meaning that you actually, for example, you write the mathematical equation, there are a bunch of variables in that model. So
Yes.
you know that those variables influence the outcome of that system. So
Okay.
by manipulating or by manipulating those variables, you know that, okay, how the output of the system can vary. So when I say input and output, it might be confusing. I can give you a very simple example. It could be, for example, one of the classical examples is about ads, like how much money a company has to spend on ads. There are different kinds of ads. For example, you can spend some money and put an ad in a newspaper. You can put an ad in the radio. Maybe you can
Exactly.
put an ad in the TV or
Yes.
even YouTube or anywhere, right? There are several platforms to put an ad.
Yes.
But then uh, allocating same amount of budget to all these ads is not a good idea, because it could be the case that the customers of this particular product belongs to a particular category. For example, this is a product that is aimed at teenage people, or
Yes.
for example, it is aimed at just students, right?
Yes.
In that case, those students in nowadays, they don't actually read much of newspapers. Maybe they don't even read
Yes.
they don't listen to radio, not even TV, right?
Yes. Yes.
An easy way would be giving an ad on Facebook or giving an ad on YouTube, rather than
Yes.
spending money to actually do on TV. So you could have such kind of, so you for that, you need to know for your product how much impact each of these has. For example, you put like 1,000 rupees for ad in TV. I will go for just 2 examples so that it is easy to explain. For example, there is TV and there is radio.
Yes.
And putting 1,000 rupees on TV and 1,000 rupees on radio
Yes.
may be not the best solution, because all your people might be listening to TV more. So it's better to put 1,500 for the TV and just 500 on the radio, right? So these kind of, but then how would you know what is the exact amount to put, right? For that, you need to
Now,
know.
one second, when
Yeah.
you talk about Facebook advertising, there are now tools available where you can figure out how many people have actually, clicked on your ads.
Yes.
That is not
Yes.
possible
Yes.
in other
Yes.
platforms, Yes.
Yes. So
And there are
these
even tools now available. I was just watching one, video yesterday where you can exactly track the individual who has clicked on your ad. There is some
yes.
available.
Yes, I mean, so we started with modeling the impact of such system, right? So means having what's the impact of putting money into maybe TVs and radios or maybe Facebooks, right? So the thing is, once you model the system, you know that putting an extra 100 rupees on this particular ad increases your product sales by this %, right? So having that knowledge helps you to rightly allocate your budget to the right kind of ad. So this is one example I gave you, where having a model of a system, how it actually helps you to do things. You could extend, or you could find out similar such example. For example, predicting the price of a house, right? You would need to know how much this house might be worth in like 10 years. So for that, you can use what is typically the price per square feet of houses in that particular area.
Number of
How many? Exactly, number of bathrooms, number of bedrooms. So there are different parameters that plays into the price or cost or the price of a house, right? So you can essentially model this. So having this model helps you to actually even invest better, right? For example, you know that in a particular area this price is going to shoot up or do this, so you actually maybe buy a property there, right? So these kind of capability you actually get by modeling the system. So let's go back to the other thing about the data, right? So when you traditionally do these models, you actually have a lot of assumptions in place, but then those assumptions exactly doesn't give you the actual result that correspond to the real world. So later on, when we had enough computing power, one of the solutions that came was, let us collect the data. So Manhal just said about, there are tools that give you which all people actually have clicked on a particular ad, right? So that is a kind of data, right? You can use such kind of data to actually come up with a better model than your classical model that you write on pen and paper, right? Or you could even use the classical model and then just learn the corrections to that model from data. So you don't completely eliminate the classical model, you just learn the corrections from data. Nevertheless, you can actually use data to actually get a better model of whatever system you are trying to model. And as an example, so when you have a lot of data, so people or human beings, or technically, I mean, it was always nice to have linear systems, because linear systems, the good thing about linear systems is that the input to output mapping is always linear. Means, have a certain change in the input, the output changes linearly. There is no non-linear relationship between the input variables and the output, right? Having such systems, it is easy for us to understand. For example, as I said about, if the model of the ad, for example, for the TV and the radio, you have for example, simple 100x plus maybe 200y is equal to the increase in sales or something like that. That just by increasing x by this much amount, the output is going to increase this much. But then if you have a non-linear relationship, it is very difficult to actually understand. So it is always easy for us to interpret a linear model. So so typically data scientists or people who actually work with data, the first attempt when they have a bunch of data is that they try to see if your output can be predicted using a linear model. So that is the first thing you do.
One common way of doing that is you take the logarithm of the data.
Yes, I mean I mean, those are like, for example, data pre-processing techniques. You need to
Yes, yes,
actually
yes,
adjust the scale,
yes,
normalization.
yes, yes,
Those are actually details on how you implement the stuff. But then what I was trying to say is that,
yes,
you try to actually do it linearly. If the linear system works, it is well and good, right? If it doesn't work, then only we would go for a more complicated method that is based on non-linear approaches. But so let us just concentrate on linear approaches. So in
yes,
case of linear approaches, the base method that you start with is regression, right? Where you
yes,
have a bunch of parameters, you have an output. You can have one output or multiple outputs, but then depends on kind of regression technique you use. Then you
yes,
try to learn a mapping between this input and output. So ultimately, the equation or the model you learn has
yes,
a has a linear relationship to your output, and having this relationship learned from data would
yes,
be more accurate than you trying to mathematically model it. For example, imagine the case of the ad itself, right?
yes,
In such a problem, you don't even know, right, how much money to put on TV ad, right? It would be just like you are a blind person throwing stones at the mango tree, right? You
yes,
put
exactly.
10,000 and then see, okay, maybe this might work. But
Yes,
actually, it was the case that you should have put more money into the radio rather than on the
yes,
TV, right?
yes,
So you would make more mistakes by doing that. But then
yes,
if you already know the data that, okay, more people or the targeted audience of your product listens to TV more or
yes,
listens to radio more than
yes,
TV,
yes.
you could actually put more money into the radio upfront itself rather than making the mistake and then correcting your actions later, right?
What you can do is you can actually allocate very small amount, such as 100 rupees each of the categories,
Yes,
and then see,
yes,
which is
yes,
actually having the most
yes,
impact.
yes.
Yes,
Yes, I mean, yes, this is one of the ways you can do. For example, as Manhaj has said, right? But again, it depends on the kind of problem. For example, there are problems that allow you to actually do these kind of mistakes. For example, like you put 100 rupees, but then it could be the case that, but means you get a next chance to put more corrections there. But then
yes,
there are cases where you cannot do these kind of trial and error. For
yes,
example,
yes, yes,
yeah,
yes.
maybe you are designing an airplane, or maybe you are
Yeah,
designing some
exactly. And
yeah,
the
yeah,
stakes are very high, there. The stakes,
exactly,
yeah,
exactly. So it depends on the stakes you can.
yeah,
So I mean, calling for the modeling means like having a right model to do the stuff makes a lot of sense. So one example I would say is, for example, again, we'll come back to the airplanes, right?
yes,
Imagine, I mean, for an airplane, there is an optimal amount of material you can actually use to the for the flight. And when the airplane is flying, you could see that, so the traditional airplanes, you could see that the wings were flat, right?
yes,
Later on, nowadays, you can see the wings are actually curved upwards at the edge, right?
yes, yes,
That solution came as a result of a simulation, which actually said that from the data, it showed that having a curved wings at the end actually has a better fuel economy than having a flat wings,
yes,
because of the aerodynamics and the airflow and all those things
yes,
actually.
yes,
So yeah, so this is one of the crucial insight that came by modeling the system rather than you trying different models and then trying out, okay, because each time you try a different model, you are actually spending money, right? And if it doesn't work, yeah, you have to scratch away all the things and start again from scratch. You put more money in, and then so the amount of trial and error you do is very expensive, so you can actually avoid that by
yes,
having a good model of the system. Yes.
exactly, exactly. So one, thing which uh, most of the aspiring data scientists, would love to, know is how widely is linear regression, used. You said there are non-linear
Yes.
techniques also,
Yes. Yes.
but so
I
that's
mean,
the starting point, huh? Linear regression.
yes. Yes. Linear regression, for example, any kind of statistical data science techniques, I mean, linear regression is where you actually start with.
But
So again,
one thing is that even linear regression is very vast because
yes, it is very vast. I mean, there are lots of, so even for example, when you do linear regression, there are assumptions in place. For example, one of the core assumptions of linear regression is that they assume the data is IID, it means it's
yes,
identically distributed, right?
yes, yes, yes,
Now, imagine the case you have a data that is not IID, that doesn't have this, that doesn't fit to this assumption. And then you try to use linear regression on that data set. Of course, it is not going to work. Why? Because you have an assumption that linear regression works only on the data that has an IID means it has an identical distribution, right? So
yes,
what I was trying, yes. So so the question of how widely linear regression is used. So as long as you have a data set that actually follows the assumptions of linear regression in place.
Yes.
The first method you can actually attempt is a linear regression. See whether you are able to actually predict the system, or whether you are able to come up with a system. And depending on the accuracy of your predictions,
Yes.
you actually can actually think about whether to adjust your method or use a different methods. That means one of the questions you have in your mind is, how do you check the accuracy of your system?
Yes.
So what you do typically is that you have a bunch of data set. For example, you have 100 data points or 200 data points, right? So what you essentially do is that you use whatever techniques. For example, let us take linear regression. You
Yes.
only use 150%. A rule of thumb is around 80% of the data. So you take 80% of your data, that is around 160 points in this case. You take your 80% of the data and then you create your model out of it. Once you have the model, then you use the rest of the 20% of the data to test the model. Means this 20% of the data, the model has never seen this data, but it comes from the same data set. So
Yes.
by doing that, you can actually know whether your model is accurate. For example, that is how you know whether your model. If you learn a model from a bunch of data set and you test your model on the same data set which you are trained on, of course you are going to get 100% accuracy, because your model is very much derived from the same data set. So it is essential that you don't use the same training data set to test your model. You use a data set that is not mixed with the training data. So one of the techniques is like, you split the data set into two: test data and train data. And then you learn the model with the trained data, and then you later test. And suppose your accuracy is low. For example, when you tried the test data and then you see that your model accuracy is low. And that is a point where you actually come up starting to ask, maybe adding more parameters to your model might be better. So one of the assumptions of linear assumptions again is that you kind of know how many variables already interact. For example, like again, let us go back to the TV, Facebook, and radio, right? And the person who is modeling only considered TV and radio, but actually most of the product sales went up due to ads in Facebook. But then he didn't actually consider the Facebook variable at all. He only considered TV and radio. And then when he makes the model, he understands that, okay, his model doesn't fit, right?
Technically, that is called as specification bias.
Yeah, exactly. Yes. So that is one of the things where you start think of how to start changing your model, maybe adding more parameters or making your model more complex, maybe eliminating some of the variables. So many things you start playing around with it. So that is how. So I was saying how the accuracy helps, or predict how predicting using a test sets helps you to refine your model to get a better model to actually do these things.
So Michael, this is one thing. The other rather very important thing is that when you actually analyze a problem and when you come up with what's working, what's not working, there you are not arguing for a particular model, as in you're not going to present to the to the company's boss that this is the model I used. You are going to actually make a case, a solid argument, right?
Yes.
So in there, your understanding of business domain, business knowledge is, I think, very important.
Yes. I mean, I absolutely agree. For example, if a data scientist is trying to model a data, he got a bunch of data and then he tries to make a model out of the data, and then he doesn't have any knowledge of where the data came from, what kind of business this data came from. It's very much would be the case that whatever prediction or whatever model he actually made may not actually correspond to the actual model. Let me think of an example in this case. Okay. Let's go with the example of for example, let's go with the example of price of a property in a particular place, right? Me being from India, I know that a property in Bombay and Bangalore is, of course, on a higher margin. Means you have a premium you have to pay because of the point you are in, right? But a person who sits in South Africa tries to model the price of the house, and he didn't account for the fact that Mumbai and Bangalore is a premium location. You don't account for that fact. Of course, your prediction is not going to correspond to the actual results you get, right? Here, what variables you need to actually include comes directly from your knowledge that
Yes.
okay, houses in Bangalore and houses in Bombay
Yes.
are sold at a premium price, right? So
Yes.
maybe that helps you to introduce a variable.
Yes.
I mean, when you introduce a variable, those variables has a physical meaning, right? That
Yes.
physical meaning comes from your knowledge of the business. If you don't have the knowledge of the business, how would
Yes.
you actually even assign the variables? You cannot just say X, Y, and Z, and then maybe you would be able to model the system, but then you don't know what X, Y, and Z is, right? So
Exactly.
this is where the business knowledge comes or becomes crucial.
Exactly. Yeah, you actually hit the nail on the head actually with this example. And that's where your understanding, but your understanding of business knowledge also goes up as you spend years in the business.
Exactly. Yes. Yes. I mean,
So
yes. I
uh,
mean, so typically what happens, at least in the industry, is that, I mean, a person working for a particular firm,
yes,
he starts as a data scientist, he learns a lot of techniques. So he learns a lot of techniques on how to model the system or what kind of models and things exist. He switches to a different firm.
yes,
He still have the capability to use or how to use a model, but then he may not know what the variables in the model corresponds to, right? So that thing he might be very specific to the new company he joins. So he
yes,
learns more about the business, and that helps him to actually, so you have a lot of transferable skills between the firms, because I mean, the way you do linear regression is the same in company 1 and company 2, but the
yeah.
variables you use
It
or
comes
the
from
physical meaning of the
experience.
variables, comes with
Comes
the
from your
experience. And
experience, comes from your knowledge, because experience
yes,
only adds to your knowledge of the business.
yes,
It's
exactly.
simple.
Yes, yes. I mean, another thing what people typically, or when people, I mean, at least I used to make these mistakes. For example, you get the data set, you sit in the class, you understand, you understood everything about linear regression, and then you implemented the method, and then you understand, it doesn't look right on the predictions. And that is when you actually look at where you start looking at whether this data set actually follows the assumptions in place, right? Whether this data actually has is following all the assumptions of linear regression, right?
Yes,
And which also comes with experience, right? A person who is novel to the field may not actually consider or may not always think about the assumptions in place when you create a model. But
yes.
yeah,
No, so the message that comes out of this is that you are not going to have first-hand understanding of the business knowledge at a very early stage, maybe when you're
yeah,
college. But what you
yes,
can do is you can actually acquire the skills
yes, exactly,
of
yes,
understanding what linear regression is, because these skills are you are going to utilize it in
yes.
your
I
role.
mean, I have a good example in this. Is, for example, a person going to the gym, you actually do dumbbells and then do kind of exercise for the biceps, right? But in
Yes.
your real world, you never actually deal with the dumbbell, right? I mean, you
Yeah.
don't have to pick up
Yeah.
dumbbell, right? But then you
Completely.
do that in
Yes.
the gym, helps
Yes.
to build muscles, which
Yes.
can help you to actually do other tasks that require
Yes.
muscles, right? So that is the way you need to think about it.
Yeah. So you
So
train yourself,
exactly, yes, yes,
for
yes,
for I mean you're training your mind and body, simple.
yes,
So
yes, yes,
to
yeah,
make sure that you are up to the mark when situation
yeah,
demands. You know.
exactly, yes,
Uh,
yes, yes,
yeah.
yes.
Thank you, Michael. Actually, so much.
Yeah, no
For
worries.
giving us a deep insight, which is coming from your knowledge and experience in
Uh,
industry.
I mean,
Okay.
thank you, Manha, for giving this chance as well. I mean, this is the first podcast in my life. I think, yeah. I'm really happy I was able to
I
say.
couldn't have actually thought of a better person to start this podcast series with. You being a robotics engineer in London, I mean, you are actually sitting at the top of the what is the data science pyramid, right?
uh,
Yeah.
yeah, I mean, those lots of kind words there, but
Yeah.
yes.
Thank you. Thank
Yes.
you, Michael.
Thank you. Thanks a lot for the
Thank you.
opportunity.
Thank
Yes,
you.
thank you.
Thank
Bye
you.
bye. Yeah.
Yeah. Thanks.